Orientating the needles, the magnetic paint consists of needles in a binder system, and to get the optimum result magnetically, you need to align the particles as much as possible in the direction of the tape, which is the direction in which the signal will be written later on. It's done by magnets, and the next stage is drying the product. We now have, as we leave downstairs, we have polyester base film coated with a wet paint. And we need to dry that wet paint as fast as possible. And that is why we have a dryer. This is a nitrogen dryer, so it is the drying is done in nitrogen atmosphere. At elevated temperatures, temperature ranges from approximately 70 to 110 degrees C. The majority of the nitrogen is circulating inside the cabinet. A small portion is taken out and is led to the other room.
Why nitrogen?
Yeah, I'll explain that in the other room, because that is a key factor.
So it's traveling.
The economics of this machine.
It's traveling through here at what speed?
It's running at the same speed everywhere, maximum speed 800 meters a minute.
Okay.
Operational speeds at this moment 100 to 300 meters a minute.
Okay.
So the majority of the nitrogen is circulating inside the drying chamber. Part of it is taken out, taken to the next room.
So would you say about the same speed as fast forward? Takes about a minute to...
Yeah. Why nitrogen? If you operate in air, as the old coaters did, there is always the risk of an explosion. Because the solvents are flammable, and in combination with air, with oxygen, you can get an explosive mixture. To avoid any explosions, we measure solvent concentration in the dryer when in air, and we are only allowed to run a solvent concentration in the air of 25% of the lower explosion limit, which is a very low solvent concentration. Disadvantage of that system is that it is very, very difficult to get the solvents back, because the concentration is very low. It's very difficult to get them back. So we incinerate them. But solvent prices are extremely high, and incineration gives you back some energy, but compared to making hot water with gas or with these solvents, you better use gas. So from an economic point of view, you need to do recovery of your solvents. So when in nitrogen, the absence of oxygen makes the risk of explosion zero.
Yes.
So you can run at any solvent concentration in the dryer you want. So solvent concentration in the nitrogen dryer is very high. If you take that and you cool down the gases with the solvents will condense. So this is a very big refrigerator. Which cools down the nitrogen with the solvents to approximately minus 20 degrees C, and the majority of the solvents will condense and will be reused. Only problem is there's some water inside, because you use a magnetic powder, which is a very fine powder, which introduces some water, and if you would use it over and over and over again, you would end up with a lot of water and very little solvent. That's why we use a molecular sieve to take out the water. The material we recover is we recover 99%, and quality of the product is exactly the same as it went in. So we need some filtration because you get some particles in the solvent, but after filtration it is the same. So we can reuse the solvent, which is a major contribution to the cost price. So that's why we're using nitrogen.
Ah.
I told you if we did the coating in oxygen, we would measure the solvent content to avoid any risk of explosion. In the nitrogen system, we measure the oxygen content of the nitrogen, and we shut down the coater if it's over 3%, because if you go to 5% oxygen, you might have a possibility of an explosive mixture. Go down up to the line. Once the product is dried, it is almost ready. Only thing is that the coating is way too rough for the high frequency response. So it is calendared. Calendar consists of 2 heated steel rolls and 4 compliant rolls. The compliant rolls are pushed with very high pressure to the steel roll, and because the compliant roll is a little bit deformable, you get a zone in which the tape is compressed and heated, ending up in a decrease of the roughness to roughness that is appropriate for the high frequency response. And the last step, cooling down and winding the product to the rolls as we see them outside. Two rolls like this with a width of 660 millimeter and a length, depending on product, of 6 to 9 kilometers. Bulk rolls are stored here for 2 reasons. First of all, directly after coating, the coating is very prone to wear, so it stays soft still, and it will harden out over time because there is a hardening system inside. The other is that we slit to the market demand, because you can slit the product in different widths and lengths, and you have to prepare way in advance the coating process, but slitting can be done in a matter of a day. So if the half product is stored and on demand, it is slitted to the correct width and length. This is slitting. Slitting operation is a number of slitters, starting off with 3 slitters, which are used to make compact cassette audio tape, with cassette tape, 3.81 millimeters, going from 1/4 inch two quarter-inch slitting machines, one for reels, one for hubs. Slitting is done, and you can see that the best the white slitter. It is in principle, it's not slitting, it is cutting the tape. It is like a rolling. We use in principle a rolling scissor to cut the tape. Half-inch machine, that is the only machine we didn't acquire from MTech, because we used to make videotape, and the width of videotape is half-inch. So we had our own half-inch machines. We have now none of the other widths, so that's what the part we acquired from MTech.
Is this slitting right here?
Sorry?
Is this slitting?
This is slitting at the moment, yes. Only part, because this is a small burl hole, and we're only slitting part of it. You can see there, it's making the
Those are quarters.
Sorry?
Those are quarter pancakes?
Those are, no, this is 3.81 millimeters.
Oh,
so this is the cassette product. You look there, you can see the knives.
Yeah.
The knife is a very thin knife. The bottom roller is has gaps in it, in which the thin knives go in a small way, and what you get is in principle a scissor with an endless length, because it will roll around. Is standard way of slitting products, magnetic products, so it's nothing special to.
This is 1 inch?
This is 1 inch, yes.
This is what I'm using.
And this machine can be adapted for 2 inch as well. So we take out the slitting box, put in a slitting box with 2 inch separation between the knives, and change the rewind system to 2 inch. Okay. So that, in short, very short, is the production process for magnetic tapes.
Okay, thanks. Thank you for that.
You're welcome. Nee, maar had ik ook toen ik ging werken, dan dacht ik ook van. Maar je mailing je snijden?
Well, I should be using the other stuff.
900.
Yeah.
That's a real high output. That's our, main product for
Yeah.
studio purposes.
I should be using that.
Ja, dat is. Ja, dat is niet echt alleen maar.
That's a little, that's a plus 9.
Nee, alleen echt. Maar daar werkt een 500 man. Ja, en wij hier ook 1000 man werken in de 54. Waarvoor ook?
Depending on what you're recording, and also on personal preference.
Yeah.
Some people like to use 911, some people like to use 900. So it's real personal.
Yeah, okay. I think I'll be going 900.